In this video, let us continue to solve more problems based on general solutions of trigonometric equations. Alright, so here we've got a problem which reads like this. It says, find the general solutions of cos theta equal to 1 by 2. Alright, so now what we have to do is, we take this equation and write it like this. We write cos theta equal to, now 1 by 2 can definitely be written as cos of pi by 3, right? So now what we're doing when we do this is, we are changing this trigonometric equation into the form of this one. That is, this is of the form cos theta equal to cos alpha, right? So for this particular kind of an equation, we've got a separate general solution for it. So that general solution is theta equals 2n pi plus or minus alpha, where n is an integer. Alright, so this is the general solution for a trigonometric equation of this form. Cos theta equal to cos alpha or sin theta equal to sin alpha. The alpha is that angle or the value that satisfies a particular equation. Alright, so in this case, the half is written as cos of pi by 3, and for this kind of a trigonometric equation, as I've shown it to you in the previous video, we are writing the general solution like this. Alright, so now the general solution for this particular equation, cos theta equal to 1 by 2, is theta equals 2n pi plus or minus alpha is nothing but this angle, which is pi by 3. So therefore 2n pi plus or minus pi by 3, where n, again, it is an integer. This is an important part of the general solution that we are going to write. So you need to write n is an integer. Alright, so that ends this problem. Let's quickly solve another problem. So we've got another problem here which is like this. Cos 3 theta equals minus 1 by 2. That is nothing but find the general solution of cos 3 theta equal to minus 1 by 2. Alright, so let's solve this one. Cos 3 theta equal to, now minus 1 by 2 can be written as what? There is a huge difference between just 1 by 2 and minus 1 by 2, right? Now, how can you write minus 1 by 2? Cos of what gives you minus 1 by 2? So, cos of, there are two angles that can give you minus 1 by 2. First of all, before I go to this part, there's a small explanation to do. Well, not that, it is required, but for those who have maybe missed that part or those who don't remember that, well, you can use it now here. Alright, so here it is. You have to go a little bit back to the allied angles part of trigonometry, alright? So we have a cos of something, we don't know what, it should give you negative of 1 by 2, right? So now cosine of what can give you minus 1 by 2. Now we need to know two things here. The first thing is, when you take the quadrant, alright, you have this, right? A, S, T, C. In the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only the sine and its reciprocal are positive. The third quadrant, only the tan and its reciprocal are positive. And in the fourth quadrant, you can see that cos and its reciprocal are positive. So that shows we have to ignore these two, right? You cannot use these two because it gives you a positive value. But here we've got a negative value. So we need to choose either this or that. In this case, you cannot choose 90 or 270. This quadrant is both 90 plus theta or 180 minus theta, right? And the third quadrant is both 180 plus theta or 270 minus theta. But we also know another thing. The second thing is that, that from this topic, the 90 thing changes off. If you write cos of 90 plus theta, that becomes sine, irrespective of what the sine is and all those things. But we know that the odd numbers, the 9s, the 27, it changes your cos to sine and sine to cos. If you need more details, please do go back to the previous video and you can have a look at it again. Here I'm being a little brief about these topics. Alright, so now we definitely have to choose 180 minus theta or 180 plus theta. That's up to you. So what I'm going to do is I'm going to choose 180 minus theta. So 180 minus theta. Now what should be theta here? Now for that theta, you can go back to this one. Cos theta is 1 by 2. What is the theta? It is pi by 3, right? It's 60 degrees. So here you replace it by pi by 3. The theta is replaced by pi by 3. So we know that cos of 180 degrees minus theta equal to minus of cos theta. And just to get this negative sign is why we are going through all this. So what I'm going to do here is I'm going to write cos of pi minus pi by 3 is what I'm going to write. So this is nothing but cos of 180 minus 60 degrees. So now what I'm going to do is cos 3 theta equal to cos of, now what is pi minus pi by 3? Pi minus pi by 3 is nothing but, you can do your calculations and we get 2 pi by 3, right? Now finally we've got this trigonometric equation into this form. So if you do cos 2 pi by 3, you get cos 120 degrees. I think, yeah, it is 120 degrees. So if you work out cos 120 degrees, you're going to get minus 1 by 2. All right. So in that way, we have not manipulated this trigonometric equation at all. I mean, we've manipulated it, but we haven't changed what it means. So what we've done is we've changed this form of trigonometric equation to cos theta equal to cos alpha, the same thing. So for these kind of trigonometric equations, we have a general solution. So that general solution is given by, this one. I'm not going to rewrite this again since it's on the same page. All right. So in this case, the theta is nothing but 3 theta. So 3 theta equals 2n pi plus or minus alpha is nothing but 2 pi by 3, where n is an integer, as always, at least in the general solutions of trigonometric equations. So now 3 theta is 2n pi plus or minus 2 pi by 3, but we don't need 3 theta. We need the general solution, right? So that is theta equals, just divide both sides by 3, or, as we say, just push the 3 to the right hand side. So 2n pi divided by 3 plus or minus 2 pi divided by 3 goes there. So 3 times 3 is 9, where n is an integer, right? So this is the general solution of cos 3 theta equal to negative of 1 by 2. So what I'd like to tell you before I end this video, I mean, this is it. This problem is done, and therefore that ends the video. But before that, what I'd like to tell you is, if you're not too sure about your allied angles, that is this part, please do brush it up and come. I mean, you really need to watch these videos with this being really understood well by you. So please do go back to these videos, understand this, and then come back. This is going to be so much more easier for you. Alright, so that ends this video. I'll see you in the forthcoming videos with more problems based on general solutions of trigonometric equations.